All right, so what we have here is a cylinder, and it's part of a light post. And if you notice, it's 35.5 inches out of the ground, and its circumference is 4 feet 9 inches. So what we're going to do is to find the volume of concrete in this pole. So let's start back here. It's 35.5 inches above ground. Oh, we don't need the height first, we need the radius first. We know the circumference. So if we take the circumference, which is 4 feet 9, 4 times 12 plus 9, and then we're going to square that. Oops. We're going to square that. No, that's the circumference. Oh, divided by 2 pi. That will be the radius. So the radius is 9 inches squared pi. And then that's the area of the base times the height. And the height here was 35.5 inches above ground. But there were 48 inches below ground because you have to go down 4 feet for frost proofing. Oops. And that will be the volume in cubic inches. Divide that by 1728 because that's how many cubic inches there are in a cubic foot. So there's about 12 cubic feet in that pole. 12 cubic feet of concrete. Here's another one. This is out in front of the Health Education Center. And the girls here are measuring this to figure out what the diameter of that cylinder there is. Well, this cylinder, if you look here, is 52.5 inches, I'm sorry, centimeters, plus 22 centimeters below ground, and it's 89 centimeters in diameter. So we're going to take 89 divided by 2 pi, because that'll be the radius, and then we're going to take that, square it, times pi, oops, delete, times pi, and then times the height, which I'm going to go back to that other picture so that you can see the height was 52.5 plus 122 is 174.5 centimeters, 174.5, and that's going to have 109,000 centimeters cubed. We're going to have to divide that by 2.54 to the third, because that's how many inches it'll be, and then we're going to divide that by 1728 to get how many cubic feet it is, so about 3.8 cubic feet for that pillar. This light here is 36.5 inches tall, and it's 2 feet 4 inches in circumference. So we're going to take 2 feet 4, oops, 2 feet 4, which is 2 times 12 plus 4, divided by 2 pi, and the radius is 4.5 inches, squared, times pi, times the height, which we got as 36.5 inches, is 2,277 cubic inches. This one is kind of interesting. What we're going to do is find out how much the volume of this whole thing is. And what's interesting about it is it's a hemisphere on top of a cone. So let's first of all find the radius. The radius of this item is 2 feet 1.5 inches. So we're going to take 2 times 12 plus 1.5 and then divide that by 2 pi, and we get 4 inches is the radius. So now I want you to look here, and let's take care of the hemisphere up on top. That's the hardest part. Well, the hemisphere is half the sphere, and the sphere is 4/3 times pi times the radius cubed. Oops. 4/3 pi r cubed. So that's the hemisphere. And then we're going, and then we're going to add to it the sphere. I'm sorry, the cylinder. The cylinder, you notice, is 39.5 inches tall. So the radius is 4 squared pi, so it's pi r squared, times the height, 39.5. So what we did here is we took the first section, which was the hemisphere, and added to it the cylinder at the bottom, and we got the total volume to be 139,000 cubic inches. Let's divide that by 1728. I did some math wrong there. That's not 80 cubic feet. Let's go back up here and let's see if we can find our mistake. Okay, so we're in cubic inches. 4/3. Oh, I see. Delete. Four-thirds pi r squared. Okay, now it'll be right. And divide that by 1728. So it's important to check your work because I knew that couldn't have had that many cubic feet. Next one, here's a cone. Actually, it's a frustrated cone because if you notice the top part is cut off and it's covering my bird feeder. Here I show the comparison between the volume of two objects. Here's the ladies' basketball. Both of them have a volume of 391 cubic inches. But if you notice, the surface area of the ball is about, oh, let's see here. Let's do the math. 321, 259 is the ball, or the cube has about 1.24, 1.25 times as much surface area. So if you were trying to heat both of these buildings, this has a lot more surface area to lose heat from, even though the volumes of them are the same. The volumes are the exact same. So a sphere is almost a perfect shape for keeping in heat, or because it encloses the maximum amount of volume in the minimum amount of surface area. I think that's our last one.